So good day. Today I will be explaining experiment number 5 entitled Loops, Subject Embedded Systems Laboratory from section E01, CPE109L. So my name is Laurence Navarro from group number 4. So the date of performance is on January 22, 2021, and the date of submission is January 24, 2021. So our professor is Engineer CYREL O. MANLISES. So again, I am Laurence Navarro, CPE109L, section E01. So today, I will be discussing first is the introduction, second is objectives, third, materials, components, and software used, fourth is the procedures or the video demonstration of the laboratory experiment 5, and lastly is the PDS questions and answers. So next, so for the introduction, so loops are programming structure that repeats a sequence of instruction until a specific condition is met. So in NI or National Instruments LabVIEW 2020, there are two loops available, which are the for loop and the while loop. So for loop is used whenever the programmer knows the exact number of iterations. As for the while loop, it is used only when the number of iterations is not exactly unknown. So for this experiment, the application of loops is done using the given diagram, which converts the total time in seconds or the input into its equivalent hour, minutes, and seconds. While loop was used, or the while loop was used to iterate the program, and some modifications in the input and output was done, especially in part 2 and 3, to observe and understand how it works. So next is the objectives. So second part is the objectives. The objectives provided in the laboratory manual that the students should attain after accomplishing the experiment are: first is to create new project and VI. So this was done by creating a new project and selecting the blank VI, which the front panel and the block diagram will pop up on the screen. So next is to use while loop to execute codes repeatedly. So after creating the program, the structure of the program, the while loop, so under structures was inserted in the block diagram for us to not click run every time. So next is to modify the block diagram based on the loop condition. So this was done during the part 2 and 3 wherein the certain output and inputs were placed outside the loop condition. So next is the materials, components, and software used. So as for the materials, components, and software used, the software used in laboratory experiment 5, which is entitled Loops, is the NI LabVIEW 2020 Community Edition, which is a system engineering software for applications that requires test, measurement, and control with rapid access to hardware and data insights. So the application was downloaded for free with 40 days free trial. So next is the procedures. So the next video is a video demonstration on how I accomplish or how I performed the experiment number 5. So for the video demonstration on how I performed the experiment, so basically there are there are three different parts of the experiment for the lab activity 5. So first part is using loops. Second is to explore the functionality of while loop output tunnels. And third is to explore the functionality of while loop input tunnels. So let us first start in the using loops or the part 1. So these are the objectives which I mentioned a while ago. So next is to create a project and follow the block diagram and front panel as shown below. So we need to create a project. So once we press the create a project, there will be a pop-up So we will select blank VI, so and press finish. So the front panel and the block diagram will show in the screen. So we need to follow the similar or the same um, components in the figure. So in the block diagram, we need to put um, the quotient and remainder. So quotient and remainder. We need to put a a numeric constant for this side, which is 60, as seen in the image. So next is 3600, create constant. And as for the left side, this is just a control. Um, so we need to create control. So let us rename this as total time in seconds. So and view as icon. So they are similar. So next is that we need to connect this remainder at the other side or the x-axis of the other component. So remainder here. Next, we need to add indicators. So how can we create this indicator? So by right clicking and then create indicator. So similar process and create indicator. So let us rename seconds, minutes, and hours. So next part. So run the VI several times with different values in the total time in seconds control. Notice that each time you click the run button, the VI calculates the hours, minutes. So what if you wanted to click the run button once and have the VI continuously perform this calculation? So until the user clicks stop button. So place the while loop. So we need to create a while loop under structures and then while loop, then drag it down until it covers all the components. So next is create a stop button and the current iteration. So we can create that by going here, indicator. So then renaming it to current iteration. However, for this stop, create control. So view as icon. So this is the stop button. So next part is right click the current iteration indicator. So right click this and then display format and then choose decimal and then press OK. So next, change the value of total time in seconds control. Notice that current iteration is incrementing. Click the stop button to stop. So let's try to run. Let us put values first. So for example, 50. So run. So as noticed, the current iteration moves fast. So total time in seconds 50, which is equivalent to 50 seconds. So for example, we input 36. So it is equivalent to 1 hour. So this is how the program works. So we can stop the program by just clicking this stop. So explore the functionality using execution highlighting. So where can we see this execution highlighting? So under the block diagram, let us press this bulb and then let's try to run. So as noticed, every values passed in the component can be seen in the block diagram. So we can now press the stop button so to stop the process. So once we stop, the stop becomes true and then it terminates the program. So as for the next step, or I mean for the next part, which is part 2, regarding the output tunnels, so update and arrange the front panel as shown in the figure. So we will put total iterations here. So let us put first an arithmetic or the increment. So let us connect this to this. So there we go. And then create an indicator. So this indicator, we will rename it as total iterations. So next part, so select the total iterations indicator, configure the display format. So same process. So we will select this one. Right click, display format, and then decimal. Okay. So next, so highlight execution and then run. So let us observe the program. So observe the flow and then click the stop button. So when I press, so as notice, the current iteration is 3. So whenever I stop this one, so the stop here becomes true and then it terminates the program, wherein the current iteration is 4 and then it adds 1. That's why in the total iteration it is 5. So save the VI. So this ends the part 2. So as for the part 3, so week 7, part 3. So drag the total time in seconds control out of the while loop. So by just dragging this, we can place it outside. So there you go. So by running this program, when the input control is outside the while loop, what happens here is that when I press run the program, for example, it gets 36, value of 36, and then I want to change it to 3610 or 3610. Every iteration, it doesn't get 3610 since the program is already here in the loop. So it will not go back here and get the value since it is outside the loop. So what the first value enters the loop will be the value overall. I mean when the loop ends, because because it the output I mean the input control is outside this loop. So so basically this ends my video demonstration regarding laboratory experiment 5. So next is the PDS, or the questions and answers. So and for the part 1, question 3.1, list the functions of the numbered item in the figure. So as in figure 5.1, it is the given block diagram wherein there are numbers which we need to determine its corresponding function. So this is the given block diagram in the laboratory manual, wherein we perform the same output or the same components and place it in order to get the same output. So as for the number 1, so the number 1 is the iteration terminal, which can be seen in figure 5.2. This provides the current loop iteration count. So the loop count always starts at 0 for the first iteration. So the second icon, or the in figure 5.3, is the iteration indicator icon. So what is this iteration indicator? So this indicator provides the number of loops occurred in the front panel. So So this is done by just right-clicking the iteration terminal and to create and press create indicator. So next is the stop control. So figure 5.4 is the stop control icon. So this stop control also can also be seen in the front panel of the lab view, wherein when pressed, it terminates the program. So by definition, this provides a button for the user to stop the loop of the program. So the program will stop once the button is pressed while running the loop function. So next question is part 2, question 3.2. Count the total number of iterations, add output tunnel in the while loop, list the functions of the numbered item in the figure. So in figure 5.5, this is the block diagram I created in LabVIEW 2020, wherein I add the total iterations outside the loop or the while loop. So I also add the tunnel or the output tunnel so that I can connect the iteration value from inside the loop going to the outside of the loop. So um, there are three functions, numbered item, which was provided in the laboratory in the PDS. So first is the total loop iteration indicator. So in figure 5.6, as seen, this is the icon for the total loop iteration indicator. So this indicates the total overall loops occurred in the program. So next is the increment function. So in figure 5.7, this is it can be observed that the increment function contains the labeled +1. So therefore, this function adds 1 to the input value every iteration. So next is and lastly is the iteration terminal. This provides the current loop iteration count. So the loop count always starts at 0 for the first iteration. So in figure 5.8, we can see the iteration terminal icon, which is located at the bottom left of the while loop. As for the part 2, question 3.3, run the VI, notice the total iterations indicator is not updating. So click the stop button, notice that the total iterations indicator now updates. So what is the reason for this? So my answer for this is that the total iteration indicator is not updating until the stop button is pressed because the indicator is located outside the while loop in the block diagram. Furthermore, the data within the loop cannot be passed outside unless the stop condition becomes true. So next is as for the part 3, question 3.4. So what did you notice? What is the return value of the input tunnel? Explain why. So figure 5.9, this is the block diagram used in part 3, wherein as observed, in part 2, the total time in seconds is placed inside the while loop. However, for the part 3, it was placed outside the while loop. So my answer for the question 3.4 is that the input value does not change while running the program since the input tunnel is outside the while loop. So the input tunnel returns a value of 65 since the input control is placed outside. The program cannot read the current value outside the loop during every iteration. So as for the part 3, same block diagram was used in the part 3. So the question 3.5 is that on the front panel, change the value of the total time in seconds control to 80. So state your observation on the value of the input tunnel and explain why it returns that value. So my answer for this is that Placing the total time control outside the loop makes the program unable to change the input while it is running. For example, setting the value to 80 and once the iteration occurs and change the input to other values, it will still read 80 since the input control is outside the loop. Therefore, putting the control or the total time control outside the loop will cause the program to accept only the first value passed inside the loop. So, um, this ends my presentation or video demonstration regarding how I performed Laboratory Experiment 5 entitled Loops. Thank you for listening and have a great day.